So using that definition that we had on the previous page, one could obtain the standard form for the equation of a hyperbola. I'm not going to go through the derivation, but it's pretty much straightforward algebra, but fairly long and maybe a little complicated for this class. So this is with the center 0, 0. So there's the two types, remember. This is vertices on a horizontal line, which actually is the same line as the center and the foci. Okay, so it's just x squared over a squared equals y squared over b, or minus y squared over b squared equals 1. So it looks like an ellipse, or looks like a circle. Well, no, it looks like an ellipse, except there's a minus instead of a plus, right? And the way we write these in this course, we're just going to always write the minus in the middle, and that'll help clear up some confusion that people sometimes have between this version and the other type of hyperbola in this section. Okay, so notice the a squared is under the first term, the positive one, and the b squared is under the second term. And that's the way it's going to work with hyperbolas. Remember, with ellipses, the a stayed with the x always, and the b stayed with the y. That's not true for the hyperbolas. You'll see the second type, the y squared will have y squared over a squared, and x squared over b squared. Okay? So you just have to get used to this. Actually, every book seems to do this labeling of the A's and B's differently. I've seen at least 3 of the 4 possible permutations of which one you call A and which one you call B. What they're doing here is they're just making A so that you always use A to find the vertices, right? Whereas with the ellipse, you just use the bigger number. But here, see, which one's bigger doesn't matter as far as which direction the vertex is for a hyperbola. It does for an ellipse, but not for a hyperbola. So what matters is, what is that first term? Is it an x squared term, or a y squared term? So this is the second one, vertices on a vertical line. Now, how do you tell that? Well, see how the a is underneath the y? So the a squared under the y squared? That tells you you're going to go from the center, you're going to go in the y direction, a. And then you're going to go negative a from the center. So up a and down a from the center, because the a is with the y, see? And the a always tells you the vertex. That's why I've got a purple in both. Okay? So it's always that number under the positive term that tells you where your vertices are. That's the important thing to remember here. And you should probably write out on a piece of paper the stuff for an ellipse, the information for ellipse, and the information for the hyperbolas side by side, and go back and forth and compare. So A is the distance from the center of the vertex, as I said. And as I said, in the ellipse, A is in the x direction always, and B is always in the y direction. And sometimes I colored A purple and sometimes brown, because sometimes A gives the vertex and sometimes B gives the vertex, right? And the same thing with B. I colored it sometimes purple and sometimes brown. How did you tell which one is A? A is always with the x on that. But with a hyperbola, A is not always with the x. It's always in the positive term. Okay? And A is used for that happens to mean that number, A, is the direction, you go in the direction of the letter that's over it. I already said this once, right? So B is in the direction of the variable in the negative, I wrote that in an interesting order, in the negative or second term. So on this second type, you would go b in the x direction. So from the center, you would go b to the right and b to the left. And you would go a up and a down because it's in the y direction. Here, a would go left and right from the center, and b would go up and down from the center. See? And the vertex would be this way or this way. So you need to know the asymptotes. A lot of people have trouble with the asymptotes. It's not as hard as it seems. There's several ways to figure this out. One way is just to memorize this. Now, one way to memorize this is to look for patterns and compare it with the original, with the original, this is 1. Compare it with this and see if you can see a pattern. Well, look, x is over a, right? But the whole thing's just squared, right? But x over a. Here, x is over a. And then b just takes the other place. So this is a slope of the line, right? Rise over run. And the problem is, with one of these, you'll have a over b, and the other one you have b over a. And the problem is which one is which. And that's how one way you can tell is just x over a there will become x over a here. Okay? And then the b just takes the other place. Let's look at the type 2. See if this works out. So see here, here, x is over this. So x is over that. So whether you call it a or b in your head or not, whatever the number down here is that's being squared that's under the x, it's the denominator here. It's that simple, right? Whichever is under the x, that's the denominator. And the one that's under the y is just the numerator in both cases. See this here? On the second type, a is there. That'll end up in the numerator. Second type. First type, b is in the denominator, b will end up in the numerator. So it's always that way with these hyperbolas. The thing in the numerator, the asymptote, is always the thing underneath y, the number under y. The reason is because if you put this b over here, you get y over b and you get x over a, which matches up with this. What you're really doing is you're setting this equal to 0. Like, you know, like with a circle. Remember, if you set this equal to 0, it makes a radius 0, gives you the center. Well, with hyperbolas, if you make this 0, it gives you the asymptotes. So you're just setting this equal to 0. This pops over here. You do the square rule thing, and you get y over b equals plus or minus x over a. So it's always, right? So this one is going to be x over a. And then the b, y over b, you just cross multiply, and it ends up on top. And with this one, you just do the same thing. So that's another way you can remember it. Just put a 0 there and just calculate solve for y, right? So that's it. And then there's a third way I'll show you.